Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives. So here we are going to discuss one important problem in which we'll find out the derivative of this function f of x, which is equal to cos square x square, using the definition of derivative of a function f of x, which is also known as the first principle, right? So the first principle says that if we have a function, say y is equal to f of x, which is defined in some domain, then the derivative of the function f of x is denoted by f prime of x, and it is given by this limit, that is limit h tends to 0, f of x plus h minus f of x divided by edge, right? So this expression or this limit is known as the derivative of the function f of x with respect to x, where this quantity h is infinitesimally very small, right? So here in this class we'll utilize this definition or this limit to arrive at the derivative of the function f of x, which is cos square x square. So let us start. So now the derivative of this function is given by f prime of x, and this is limit h tends to 0 and f of x plus h. So f of x plus h can be obtained by replacing this x by x plus h in this function. So we have cos square, and x square can be written as x plus h square, and then we have f of x, which is cos square x square, right? And we divide this difference by h. Now here we can see that we have the difference of two terms containing cosine square. So here we'll make use of one important identity from trigonometry. So from trigonometry, we know that if we have, say, cos square a minus cos square b, then we have the expression for the difference of these two terms as negative, and here we have sine a plus b times sine of a minus b, right? So this is an important trigonometric identity which can be used here, and what we will do, we'll take a as this term, right? So we'll assume a as x plus h square and b as x square. So now we have limit, and this is h tends to 0, this is cos square a, because x plus h square can be taken as a. So here we have a, and then we have cos square b divided by h, right? So now we can write limit h tends to 0, cos square a minus cos square b is the negative of sine a plus b, and here we have sine of a minus b divided by h, right? Okay, so now let us calculate the sum of a and b. So a plus b is now equal to x plus h square plus x square. So let us solve it. So here we have a plus b square, so this is x square plus 2xh plus h square plus x square, right? So x square plus x square is 2x square, here we have 2xh, and here we have h square, right? So now let us calculate a minus b. We can have a minus b as x plus h square minus x square. So this is x square, a plus b square. So we have x square plus h square plus 2xh minus x square. So this term and this term get cancelled, So we are left with h square plus 2xh. So now let us substitute the values of a plus b and a minus b in this expression. So we have minus sign. A plus b is 2x square plus 2xh plus h square, and then we have here a sign of h square plus 2xh, and in the denominator we have h, right? So now we have to evaluate this limit where we have the product of two sine functions. So now let us take this negative sign outside, and we have limit and h tends to 0. First we'll take this expression only, that is the sine of 2x square plus 2xh plus h square, right? And then we can now take limit h tends to 0 and the sine of h square plus 2xh divided by h, right? So what we will do, we'll take the separate limit of this function, and then we'll combine sine h square plus 2xh over h, right? Because here we are going to utilize this important result, that is limit theta tends to 0, sine theta over theta is equal to 1, right? So now let us first take this one. So here when h tends to 0, then this term becomes 0, and also this term also becomes 0, right? So we are left with only sine 2x square. So we have minus, here we have simply sine 2x square, and then here we have limit h tends to 0, and now see here we can write sine h square plus 2xh over we wish to apply this result over here. So what we will do, we'll try to create a term h square plus 2xh in the denominator as well. So we have h square plus 2xh here, and this h can be written over here, and to cancel out this term we have to multiply the numerator by the same term, that is h square plus 2xh, right? Because here we would like to have a form of this kind, that is sine theta over theta, and here theta is h square plus 2xh, right? So in the denominator also we should have this theta, so we can write h square plus 2xh, but since we are having an extra term, so we have to compensate it, so we have to multiply the numerator by h square plus 2xh, right? So now see we have this term, that is sine theta over theta. So now we can write negative sine 2x square, and then we have limit h tends to 0 sine h square plus 2xh over h square plus 2xh, and now from here we can take h common, so we can now write h plus 2x, and in the denominator we have this h, and this h and this h get cancelled. So here we have limit h tends to 0, and we have h plus 2x, right? So now the value of this limit is equal to 1 due to this result, sine theta over theta. And remember, when theta tends to 0, sine theta over theta is equal to 1. So when h tends to 0, then this term, that is h square plus 2xh also tends to 0. So this is an important thing while using this result. So when h tends to 0, we can write here when h tends to 0, then this term h square plus 2xh also tends to 0. That's why we are able to apply this result to this limit. So we have now here a minus sine 2x square multiplied by 1, because this limit is 1, and limit h tends to 0, h plus 2x. Here we have 0, h is 0, so we are left with only 2x. So here we have simply 2x, right? So the derivative of this function using the first principle is now given by minus 2x. Here we have minus 2x, then we have sine 2x square, right? So now the derivative of this function, that is cos of cos square x square, is given by minus 2x sine 2x square, right? Now here we can also apply the uh, trigonometric identity, that is sine 2 theta is equal to 2 sine theta cosine theta. So here we have 2 theta, that is 2x square, so our theta is x square, right? So now the derivative can also be written as minus 2x, and for sine 2x square we can write 2 sine x square cosine x square using this result. So now this is 2 times 2 is 4, so we have minus 4x sine x square cosine x square, right? So the derivative of this function can also be expressed like this, or we can also write the derivative in this form also, right? So this is how, by using the concept of first principle, we can find out the derivatives of functions.